Okay, hi everyone. I did my presentation on the Voyager spacecrafts that have been in outer space since 1977. So the history behind it is there's two Voyagers, Voyager 1 and Voyager 2, that are exploring beyond the Earth, specifically between Saturn and Jupiter. After making a bunch of discoveries like the active volcanoes on Jupiter's moons and a bunch of discoveries on Saturn's rings, the mission was also extended because of how much more there is. But along with that, Voyager 2 went on to explore Uranus and Neptune is only one of the spacecraft to visit those planets. And the current mission is called the Voyager Interstellar Mission, which will be the edge of the sun's domain and beyond that, and maybe even be extended more considering this is still an ongoing mission. Voyager 2 entered the interstellar space in November 5th, 2018, and they hope to find more about the region and the DSN, which is called Deep Space Network. Again, they were both launched in 1977, and although the primary purpose was for Jupiter and Saturn, it's also explored more and it sends data back to Earth. So although the first one is called Voyager 1, the second one is called Voyager 2. Voyager 2 was actually sent out first before Voyager 1. Voyager 1 is a lot faster and shorter path, but as you can tell, difference between kilo per hour, there's a lot more that they're finding together. So that's a big reason for two different Voyagers, as we're discovering more than we thought. But the trajectory is what I'm mostly here to talk about, as this is our current unit and what we're learning about. First off, I'm going to talk about small visualizations on the next page, same with how it's gone, how the trajectory has been shown since September 5th, 1977. And to this 40-year history of the mission and this visualization, the pacing of the time accelerates through most of the time, especially how it started from going 5 days per second at the beginning and then speeding up 11 months per second as the planet's flybys are fast. This kind of shows how much this whole mission is going a lot longer. And there's a lot, along with this, there's like the termination shock and the helipause which are the boundaries that are created when the plasma between the stars interact and the plasma is flowing outwards towards the sun. This kind of represents what the Voyagers are discovering throughout these planets. And they're also with the simple grid models that I'll show you in the next couple of slides to show how the orange to third nose is pointing direction. So first we have this image. This is showing the opening view of the Earth orbit looking outward to the rest of the solar system. This is just like the basis one that a lot of these space trajectories are shown. And then this is both Voyager 1 and 2. This is across the orbit of Mars, slightly above the elliptical plane to avoid the asteroid void between Mars and Jupiter. And then the third one is with the gravity assist from Saturn. Voyager 1 is directed above the plane of the solar system and continues outward. While this is near the time of the Voyager 1 family portrait, I thought that's a big reason why I should show it. It's not a great picture, but as you can see, there's a lot going on, and so it shows what really their accomplishment. And the orbit of Pluto is in the gray or visible above the orbits of the other planets. You can probably tell how much farther and different it is. And again, the NASA used gray to show how, since Pluto isn't considered a planet. Thank you so much for listening, and here are my sources. The last one is the most recent article I based my thing off of. I think Voyagers was such an interesting topic to use because we're learning a lot more than expected, and it's been in outer space for so many years and probably longer, as it's one of the biggest things that is teaching NASA / America about outer space, especially different planets. Thank you.